Good morning, everyone. Thanks for coming out. So let's get started. My name is Brian Matthew. I'm a program manager in the storage and file systems team in Windows Core. Our team, the storage and file systems team, ship and develop features across all versions of Windows, across all SKUs and devices. So you can imagine your Windows RT device, we built storage features for that. Your Windows Phone, we built storage features for that. Laptop, your data center, we build storage features for that. So our team really has to think about scale at all levels of the stack and all devices. So just a little introduction to our team. All right. In this talk, so yesterday I had another talk talking about spaces as well. There will be some replicated content. However, I do guarantee, no money back guarantee unfortunately, I do guarantee that you will get some value out of this talk. We go into more depth into some of the case studies, and we talk about some of the features that we didn't actually talk about in the last talk. So, in this talk, we're going to talk about the what, why, and how of storage spaces. Namely, what is spaces? Why should I deploy? What benefits do I get? And how do I deploy? How do I put this all together? We're going to present some of the solutions that are available and certified today that you can run spaces with. And we're going to show you how customers are using spaces to solve real-world problems and get a number of benefits. So a little background. Recently, we've seen an absolute explosion of data. We've also seen a shift in the way that we're doing computing. And this has resulted in a number of challenges for vendors in how they store and how they manage their data. So Microsoft has experience in designing large public and private cloud infrastructures. Some examples of public that I'm sure you folks know of are Azure and Bing. Looking at these different infrastructures, looking at these different deployments, we found that many of them share very similar design goals. I guess my clicker is not going to work over here. Number one, you need to use cost-effective hardware wherever possible. As you scale your deployment, you need to be able to scale with a reasonable cost. You can't keep on purchasing very expensive storage. It's not going to work for your budget. Failures are commonplace and need to be treated as commonplace and not an exception. So your system needs to build in handling of resiliency. You need to reduce the single points of failure wherever possible. As your deployment grows, those single points of failure will bring down the entire deployment or have the potential to bring everything down. And that's also unacceptable. And of course, again, as your deployment grows in size, as your deployment grows in complexity, any inefficiencies in operations simply won't scale to meet that growth. And you're going to be bottlenecked by those inefficiencies in operations. So you need a system that's easy to manage and easy for your personnel to work with. Taking all these different design goals, we've developed spaces. One of the focuses for R2 have been to dramatically lower the cost and complexity of deploying and managing storage for our most cost-conscious customers, including those that deliver infrastructure as a service storage platforms. In other words, hosters. Now, everyone is saying hosters at these talks, but in reality, most of us are hosters in some shape or forms. Most of us are deploying services, have infrastructure to deploy services, whether it be for public or private cloud. Most of us are doing this today. And we're achieving this dramatically lowered reduction of cost and complexity through two high-level methods. Number one, we're disaggregating with the infrastructure, the architecture, disaggregates your compute and storage. As your compute needs grow, simply scale your compute. As your storage needs grow, simply scale your storage. These are not inextricably tied. We reduce the costs by utilizing industry-standard commodity servers, networking, and storage. And the components that comprise this stack, starting from the storage would be commodity JBODs, just a bunch of disks in a box. Commodity JBODs. These JBODs are managed. The intelligence to manage your data is provided by storage spaces, which lies on commodity servers running Windows. Clustering provides high availability. Scale-out file server provides scalable data access. And I use SMB protocol to communicate to my virtualized workload, which is managed by Hyper-V. Now, this end-to-end stack, from the storage up to my workload and all the components in between, is managed by PowerShell or SCVMM. The entire workflow of deploying your data center with Spaces, with Windows File Server Cluster, with Hyper-V, can be easily done through PowerShell and SCVMM. And we have customers today, even in just only one release, only 1 year since we shipped 2012, since we shipped storage spaces in 2012 in the stack, we have customers with their entire deployment, entire rollout, 100% virtualized and 100% managed with PowerShell. 100%. Now, this method of deploying storage is rather quite familiar. I mean, if we look at the component level with a traditional storage array in the Windows File Server Cluster, we compare these at the component level. On one side, we have Fibre Channel or SAS disk shelves. On the other side, we have shared SAS JBODs. What are these both things? Boxes of disks with controllers at the back, with redundant controllers at the back. Both of these also have some amount of storage compute, perhaps in a slightly different form, but they're still storage compute. My traditional storage array would have embedded CPUs and embedded controllers running proprietary hardware, proprietary software. And this is what you're paying for. On the other side, my Windows File Server Cluster, I have commodity components. I have commodity servers. I just have servers running Windows. These servers are easy to manage, just like any other server today, any other of your servers today. If you need to increase the capabilities of your servers, more RAM, more CPU, you want more storage throughput, you add HBAs, you add RAM, maybe swap out your CPUs. They're very easy to manage and upgrade because these are commodity servers. Okay, so at the component level, realistically, there's disk shelves, JBOD, storage compute, and storage compute. Very similar. Now, the difference between these two is the protocol used to communicate between my storage and my virtualized workloads. On one side, I'm talking block, my storage array with Fibre Channel or iSCSI talks block. I'd unmask a LUN from my storage array, present that to my compute nodes, and my workload would run on that LUN. All right? With Windows File Server Cluster, we're talking file. I simply share out a share from my file server cluster, present that share to my compute nodes, and my workload to run on that share. Okay, so file versus block. Well, what does that really mean? My workload is running inside a compute node. What is this workload using? It's using files. It's using files either on a volume or on a share. For my workload, it's the exact same thing. From the workload point of view, from the component point of view, very similar deployment model. Right? And from the capabilities point of view, we further enhance this with R2. So we have much more parity with what's available with a storage array. Both have storage tiering. Both have a form of data deduplication. Both have storage pooling. Both have availability. Both have a write-back hash. Both have offloaded copies. Capabilities, architecture, and components, very similar. Now, before we talk about spaces, I want to go into a case study. Now, I just glossed over this case study in my presentation yesterday, so let's go into this with some depth. The Windows release team is an internal engineering organization that manages and stores all the Windows build data for all the teams across Windows, all their repositories, all the branches. That's a hell of a lot of data. You can imagine there's so many different components in Windows. There's so many different teams that deliver upon those components, and those teams have sub-teams. And those teams have their own branches for checking code. That's a lot of data to manage. But this team had several issues. First of all, while they had 2 petabytes of raw capacity, 2 petabytes of capacity. Because Windows does builds every day across all these different branches, it was only enough to store 5 days worth of data with 2 petabytes. All right? The cost of their deployment, because they're using a mix of traditional and some servers with storage, was astronomical. They couldn't realistically expand their deployment to meet growing data needs because of this cost. And because of the size and complexity of the way that they're deploying storage with the mix of traditional and servers with storage, they had some individual points of failure. And because of the number of servers they had, they weren't able to guarantee that all of their deployment was on redundant power. So that was also an issue. They needed more capacity. 5 days was simply not enough time. If a developer or a tester found an issue with a specific build and that data was no longer available, that developer or tester needed to spend time to try and reproduce that issue with a newer build. That took a lot of time. You multiply that across the thousands of developers and teams across Microsoft. You can imagine how much extra time was spent debugging issues simply because the data was not available. So 5 days is not enough data. They needed to dramatically lower their dollars per terabyte, and they needed to have a scalable platform for increasing data needs across 5, 10, 15 years down the road. This is what they needed. So we worked with them early in Windows Server 2012 to deploy Spaces. This is what they saw. Immediately, they doubled their storage throughput. Doubled. And the funny thing is, when we were testing this, we found that Spaces was pushing so much throughput through their network switches that they needed to upgrade the networking inside their building and the adjacent buildings that just simply handle this throughput. They needed to overhaul the networking. They tripled their raw capacity. With their old deployment of traditional storage, they were spending $1,350 per terabyte. Compared to with storage spaces, they dramatically lowered that to $450 per terabyte. And even $1,350 per terabyte is actually cheap compared to many other solutions on the market. With the same budget, so that fiscal year, they were given budget to replace a third of their deployment with their traditional storage. They used that very same budget. They deployed Spaces. They replaced the whole deployment. With data duplication and with this tripling of the raw capacity, they saw a 5x increase in the effective capacity through data duplication. And because Spaces allowed them to use hardware, simple hardware, that provided significantly increased data density, they can stick more disks into less use of gear, they were able to call 6x in the servers. So they went from 120 servers down to 20 servers with storage Spaces. They were able to get rid of 8 full racks full of gear. And that's 8 racks, realistically, in some data centers, is an entire hallway. This is what they did with Spaces. Now, here's an overview of their deployment architecture. So they're using 20 Windows file servers connected with 10 gigabit networking. These file servers were connected to 20 60-bay JBODs with 3 terabyte disks. So you can imagine already there's a lot of disks. There's a lot of capacity. In aggregate, this configuration, this infrastructure, was connected through a 60 gigabyte switching nexus inside that building, or inside that, across the different labs in that building, to hundreds of build servers across Microsoft campus, which generate build data every single day, thousands of developers and testers across Microsoft, both in Puget Sound and globally, and thousands of internal and external partners also utilizing this data for debugging and development. Every single week, through this switching nexus to these servers, to this storage, we see 720 petabytes of weekly data volume flowing to and from this storage, to and from Spaces. 720 petabytes. That's an unimaginable amount of data in just a week. And in fact, with Spaces, they actually plan to double this deployment over the next year. They plan to put even more data on here. And this is only possible because they're using commodity components, because they're able to drive the cost down so much further than their previous deployment. $1,350 per terabyte to $450, or $1,450 to $450. So let's talk a little bit about storage spaces. And when I presented this slide, which showed a sampling of some of the Spaces certified hardware just 2 weeks ago at TechEd New Orleans, there was less gear. There was 3 less, in fact. So just in 2 weeks, we were able to add 3 pieces of Spaces certified hardware, just in 2 weeks between the 2 conferences. So the acceleration of partners jumping on board Spaces, providing hardware for Spaces, is immense. And it's only going to increase as time goes by. Now, you can go to this link here, windowsservercatalog.com. Under the storage spaces category, you can find the list of Spaces certified hardware. And you can check this list as time goes by to see more partners and more components become Spaces certified. All right? But looking at the components themselves, they're very simple. Okay, they're boxes, metal boxes, with a backplane that you connect your enterprise-grade dual-port SAS drives to. They're very simple boxes. In the back of these JBODs, there are redundant power controllers, providing resiliency against power failure. There's redundant SAS modules, providing resiliency against path failure. Okay? If one of those controllers fails, or a link from servers fail to this server, to this JBOD, the other storage controller takes over. So these are very familiar JBODs that you'd find today in traditional storage arrays. They would also have redundant power, also have redundant controllers. Redundant controllers with multiple ports, so I can connect multiple servers to them and have those servers see the same set of disks. Okay? So let's build up Spaces starting from JBODs. Here I have 2 24-bay JBODs, so a total of 48 disks. With Spaces, I'm not managing the physical disks. I don't need to worry about the physical disks. Okay? I don't create RAID groups. I don't do any of that. I take these physical disks and I create a storage pool. Or I can take a subset of these physical disks and create a storage pool, and take another subset and create another storage pool. It's very flexible. The storage pool is simply the container for isolating and managing your deployment. So I'm not managing the disks. From this storage pool, I carve out virtual disks. I can have different resiliency options, and I'll discuss that in the coming slide. But these virtual disks get presented up to Windows just as regular disks. So you can run your workload on them. You can format them with your file system, and you can run your workload on them. You can run Hyper-V, you can run any number of workloads on these disks. So they're simply disks integrated into Windows. And the way that Spaces utilizes those physical disks, basically how Spaces writes data to those physical disks, is that it distributes data across all the disks, potentially all the disks in your pool. And what this means is that this significantly improves the performance of reads and writes being serviced to those disks, because I can have parallelism. I can have multiple physical disks servicing my reads and writes simultaneously. And as my queue depth increases, Spaces will then shuffle your I/O across your pool disks. We also, with Spaces certified hardware, if I create a resilient virtual disk, Spaces will place independent data copies on independent JBODs. And this is possible because the JBODs report us information on the physical disks. So they tell us which slot the physical disk is in and which enclosure the physical disk is in. So for instance, if one of these disks fail, Spaces will automatically blink the LED on that disk. So you can easily identify, oh, this disk has failed, I'm going to pull it out and I'm going to replace it. This same capability tells us which enclosure the disk is in, and it's able to separate copies of my data across different JBODs. If one of those JBODs comes down, I'll still have the other copy of the data in the other JBOD. And when I bring the failed JBOD back up, or I replace it with a new JBOD, Spaces will resync the data. So what if a disk fails? Oh, we went through this, sorry. So what happens is because we stripe the data across multiple physical disks in the pool, we use the same capability to also rebuild your data to and from multiple physical disks in the pool simultaneously. So you can imagine that the data that was logically, quote unquote, logically contained on that physical disk that failed is actually spread across, the other copies are spread across other disks in the pool. Okay? Because it's spread across the other disks in the pool, I can use whatever spare capacity is on those physical disks, on those other physical disks in the pool, and I can take that data and copy it, redistribute the data using that spare pool capacity. By using that spare pool capacity, I can use the throughput of multiple spindles at once. So what happens if I had a hot spare, for instance, and I do a rebuild with a hot spare, I'm limited to the throughput of what that hot spare disk can give me. So if I have a 7200 RPM disk, that's 150 megs a second. 15K disk, maybe 200. But the point is, that's not fast enough. We have an internal test where we had 8 disks, 3 terabyte disks, and we simulated a failure of one of those disks. All right? So we had 2.4 terabytes of data to rebuild. Using parallelized rebuild, we rebuilt that in 50 minutes, 2.4 terabytes of data, 50 minutes, at a throughput of 800 megabytes per second, which is clearly way beyond the capabilities of a single disk. So when you have a failure, we bring your space healthy again in a much faster manner without the need for a hot spare by simply using available pool capacity. Spaces also provides a unique capability compared to many other solutions. Because Spaces provides multiple copies of my data, we actually also provide an API for applications to be able to query and get the individual data copies from all the copies that are available from Spaces. So for instance, if I have a mirror that provides 3 copies of my data, distributes 3 copies of my data across all the pool disks, I can have my API, I can query copy 1, copy 2, copy 3. What this enables us is services or applications to use that data for benefits. One of the benefits is we have a service in Windows called the Data Integrity Scanner. Okay? On volumes with running NTFS and REFS, this Data Integrity Scanner will periodically go through my virtual disks, look at all the data copies, find inconsistencies, and autocorrect from another copy. With REFS, we can go even further because REFS checksums my data, so I know if that data is actually correct. So I not only know if I have a read error, which commonly occurs with disks over time, and you only see this read error when you actually read the data again. Okay? With REFS, I'll actually know if the data is correct because I have a checksum for that data. Spaces is easy to manage. We have extensive PowerShell commandlets. These PowerShell commandlets can be used local in the box, can be used in a cluster, you can write a script with them. It's very, very flexible. And again, we have partners today, we have customers today using PowerShell for their entire deployment. Deploying Spaces, deploying their file server, deploying their cluster, deploying their workloads, even installing Windows images onto their file servers using WDS. This is all possible because PowerShell is so powerful. We have other methods to manage Spaces. You can use a server manager. We have UI in the server manager for managing my local or clustered Spaces. We have integration with SCVMM 2012 R2. So I can do the full end-to-end stack, rolling out all my servers, rolling out storage, file servers, clusters, Hyper-V networks, shares, the whole 9 yards. The whole thing can be managed PowerShell SCVMM. And Spaces is continuously available. And let's talk about that in the next couple of slides. But one slide I want to put up, and a lot of folks ask me about this information, is what is the different types of resiliency available with Spaces? Okay? So Spaces provides 3 basic resiliency options. The first option, what's called a mirror, that we absolutely recommend for all workloads, provides 2 or 3 copies of my data. By default, we provide 2 copies of the data. Okay? We have parity space, which provides 2 or 3 copies of my data. And we simply, parity space allows you to more efficiently have resiliency for your data. Parity spaces are recommended for more sequential workloads with large units of reads and writes, such as archival workloads or even a VHD library that you'd use to copy your VHD file to your virtual machines and then provision from there. And the other type of resiliency is a simple resiliency, where we only maintain one copy of your data. So if a disk fails, this is not recommended. Simple space is only recommended for workloads that you have an alternate form of resiliency, or workloads that don't need resiliency. If your workload, for instance, has a read cache, you can use a simple space. So these are the three types of resiliency options. So the gentleman is asking, I shouldn't apply the RAID levels from a controller. I shouldn't use a RAID. Absolutely. Absolutely. You shouldn't use a RAID controller, because what you should be using is what's called a SAS HBA. Just HBA. Simple SAS, essentially SAS to PCI bridge. That's really what you want. You want the most simple controller possible. Spaces provides the intelligence to stripe and mirror your data across all your physical disks presented by that HBA or presented by a number of HBAs. The performance of RAID?
The resilience of RAID.
Okay, so the gentleman is asking, how does Spaces compare to the resiliency of RAID? So, right. So Spaces stripes and mirrors data very similar to how RAID or how storage arrays would stripe and mirror the data. We simply, it's pretty much the same thing in terms of how we actually write the data to the physical disks. However, we have a couple of unique capabilities. One thing is our mirrored space actually has what's called a dirty region table. So for instance, we log every single operation that we do to the virtual disk before we actually commit it. What that means is that if there was a power failure or unexpected cluster failover, we're able to recover from that state using that log, and we're able to replay or undo records to make the virtual disk consistent again. And we're able to do this without a battery. You don't need a battery because it's all built into the space. And it's exactly the same thing for a parity space as well. Parity space has integrated journaling, so we log all operations before we commit it, such that we have that same resiliency in the event of a power failure or in the event of an unexpected failover. Again, we're able to do this without a battery. And with RAID controllers or many other controllers out there, you need a battery. And you need to potentially replace that battery every year, otherwise it can become unreliable due to the heat of the servers. Yeah. But Spaces, you absolutely want to use the most simple hardware possible. You want to use a simple JBOD. You want to use a simple SAS HBA, potentially multiple HBAs, provide resiliency and increased throughput, and simply present those disks in their rawest form up to the server for Spaces to use. All right, does that answer your questions? All right, thanks. So let's build up a highly available Spaces deployment from the ground up. Starting from two 60-bay JBOD arrays, so that's a total of 120 disks, and I have two clustered file server nodes. I would connect the JBODs to the file server nodes in a manner such that each file server has two paths to each JBOD. So I have a total of 4 SAS cables here. And each file server is then able to see all the disks in the JBODs, both JBODs simultaneously. So it has the same view of the disks. If one of these servers were to fail, the other server simply takes over. And that access is managed, that high availability is managed by Windows clustering, because it's a clustered resource. Okay? So I take all these physical disks presented by these two JBODs, and I create a storage pool. I manage the pool, not the disks. From the storage pool, I carve out some resilient virtual disks. In this case, I've carved out 3 mirrored spaces. Okay? But because I have multiple virtual disks and multiple servers, I need a way to easily manage my data. I don't want to go to whack server 1, find the stuff there, whack server 2, find the stuff there. I want to have a single place I can see all my shares, see all my storage. With clustered shared volumes, it unifies the storage across the entire cluster, unifies all those virtual disks as presented by Spaces into a single namespace. I do whack serve, whack cluster. All my stuff is there. From my CSV, I then simply use scale-out file server to present shares up to my Hyper-V compute nodes. So you can see I have a separation of my compute and a separation of my storage. And I can independently scale those separately. Architecturally, this is very similar to how you deploy traditional storage, where you purchase a storage array, you stick that storage array in, and you present your fiber channel LUNs up to your Hyper-V compute. Now I can grow this. I can add more JBODs. I can add more servers. I can add more virtual disks. As I add these components, my CSV simply scales linearly. I simply add more folders on my CSV. And I simply add more folders on my scale-out file server. It's linear scale. And it's very easy to manage in that manner. I can scale this out even further. Because these are, you can imagine this bottom part here with 4 servers, 4 JBODs. This is 1 unit. I can take this unit and add more of them. Even though these separate units here, these 4 units, are not connected physically through SAS, they're joined because they're in a cluster. So nodes on the rightmost unit can access storage on the leftmost unit because the access gets redirected through the cluster network, through the CSV. Each of these units have their own storage pools. Each of these units have their own virtual disks. Okay? CSV aggregates all this in one spot. Again, it's still linear. I've added more units, but my CSV simply scales linearly. And again, I simply share this out via SMB. Now, that customer I was talking about earlier, that's NTTX, a hoster in the UK. They're using Spaces in their data center. And this capability to simply add more of these units as more customers come online for them has made their business possible. They can't go and purchase this all in one shot. That's impractical. They don't have the number of users necessary to saturate this. They simply purchase more units, add this to the cluster. They still have this CSV. CSV grows linearly. As more customers come in, they add more units. It's very simple. Philip Moss from the NTTX team, he's the CTO over there. Where's the question? Oh, yes.
If the whole unit fails, then the data then lost.
So if this entire unit fails, like for instance, if all 4 servers fail and the JBODs.
One of those 4.
Oh, okay. So the entire unit fails. So here you have. Sorry. So one of these 4 server, 4 JBOD units fails, right? Okay. So within this unit, you have a lot of high availability. You have 4 servers already. Okay? You have 4 JBODs. Using that enclosure awareness, you can spread your data across those 4 JBODs. But even though this entire unit fails, you're having a really bad week. Okay? Maybe you went on vacation for too long and something bad happened. This entire unit failed. Because all my workload is virtualized, I can actually use Hyper-V Replica to replicate all my workload, all the data for that workload onto another box, or even onto another data center. It doesn't have to be in the same cluster. That is one method you can use to mirror, so to speak, or replicate your data across these units. But within these units themselves, there's already a lot of high availability. If you have one server fail, I'm sure you're already going to replace that server. But maybe you're...
So, for example, different data centers and the
Yes.
data center connectivity is also.
Yes, absolutely. If you have different data centers, you would use Hyper-V Replica as one mechanism to replicate your workload across to another server. And your workload, you can have SQL, you can have Exchange, and part of your workload, actually, you can have virtualized file servers providing data for your users. Yes? So the gentleman is asking, where is the configuration data for storage spaces stored? All right. So the way that Spaces writes out its metadata is that it writes it out to all the physical disks in the pool. What that means is that each physical disk knows of the entire pool state. If I were to take one physical disk, I would just go to one of these JBODs, yank a disk, stick that into another server. That, when it comes up, it'll recognize that there's 239 missing disks because every disk has a unique view of the entire pool, has a correlate view of the entire pool. So all the metadata is stored on these physical disks. There's no in-memory representation because we need to handle the case where an unexpected failover occurs.
There's no host where it's stored either. So if you lose all your nodes, you can actually just replace them and bring them up and running.
Absolutely. So if all the nodes fails, really bad day, all the nodes fails, but the storage is still there, I can swap in new nodes and it'll go up and running. Absolutely. Absolutely. Yes?
You mentioned Exchange, but Exchange is not taking, it's not using storage spaces.
So the gentleman is asking, I mentioned Exchange support spaces. So inside a VM, you can run your Exchange database.
But, SQL can write to a share.
Yes.
And use SMB.
Sure.
As Hyper-V can.
Yep.
But why is Exchange 2030 not, if you know?
Oh, I'm not as familiar with Exchange's recommended deployments. I can find out more information for you. But we expect all workloads to be virtualized. It's a lot easier for most customers to virtualize their workloads. Because you can imagine a hoster, for instance, or any IaaS customer. Simply a customer comes in, I want an Exchange database. I already have a service profile for generating that database, generating that server with the storage for that database. So I simply do that, and it's very easy for the customer to roll out new services for their clients.
Yes, I would like to be able to write my Exchange database to a file share.
Okay, I'm not sure of Exchange's full support story, so I can definitely find more information for you. Yeah, all right. Sorry.
Virtualize the clustered file service?
So the gentleman is asking, is it possible to virtualize the clustered file server? So in other words, you're saying all these machines here at the bottom level you want virtualized. So these machines, you need to have some machine with physical access, right? You need to be able to have some machine that has connection, direct connection to the disks, not through any other layer, not through any Hyper-V layer or anything like that. You just want servers, HBA, JBOD. That's what you want. And that's analogous to what you'd have in a storage array, because your servers is your storage compute in that array. In that array, you'd have controllers, and you'd have some CPUs in there. So it's analogous in that manner. You can have virtualized file servers up in the compute node. You can have those virtualized file servers. You can have a cluster virtualized file servers up the compute node. I create a shared VHD on one of these shares in this bottom layer. I present the shared VHD to a number of clustered VMs. I create a cluster. I create a scale-up file server. And that can be virtualized. And that's actually what we recommend you do. So this bottom layer simply provides the storage for everything in the top layer that's virtualized. It's a lot easier to manage. Oh, yes, sir. Sorry, did I answer your question? Yes, at the back. Sorry, I'll have to come up to you.
Let's say DB runs on SSD disks, and then you have some file share, media or file share,
Yes.
which you run on.
So the gentleman is asking, can I have different types of disks in the JBODs? And can I segregate the workload? So automatic spaces will automatically select the appropriate disks when I create a virtual disk. However, you can constrain. When I create a virtual disk, I can say I want it to only use these sets of physical disks. So I can say I want it to only use these SSDs. I want it to only use these 15K disks. Or, as we're going to talk about a little later in the deck, we can have automatic movement between different types of disks. And I'll talk about that in just a second. Okay, so NTDX. Jeremy Russell from this Windows release team, he is saying he is able to use commodity hardware. So those servers, those commodity servers, commodity networking, commodity JBODs, with storage spaces to achieve the same functionality of traditional storage as he's deploying it today at a far lower cost. So we talked about the storage platform, storage spaces, as we shipped it in 2012. Now let's talk about our R2 capabilities. We built upon that foundation that we shipped just 1 year ago. Well, actually, even less than 1 year ago, I believe. We shipped that just less than 1 year ago, and we're further delivering these capabilities. We want to minimize the dollars per terabyte and capital expenditure for deploying your storage. We want to maximize the IOPS per dollar, get the most performance possible out of the money you spend. And we want continuous availability. Whatever features we deliver need to be continuously available. And whatever features we deliver need to minimize my operational expenditure. So it needs to be easy to manage. This is what we've done. Dual parity. Minimalizing the dollars per terabyte to deploy my archival workloads. Okay? Provides resiliency to 2-disk failures in a more efficient manner of storing the data. We actually worked with Microsoft Research, our research division, our computer science research division, to develop the algorithm for our dual parity. And this algorithm for dual parity is more efficient, or designed to be more efficient at rebuild times than many other algorithms that are on the market today. We found that this is key in delivering a parity implementation. The rebuild times need to be minimalized. Dual parity and single parity are now supported with Windows clustering. This is not possible with 2012. So I not only have resilience against media failures, efficient space utilization, but I also have continuous availability with clustering. With CSV, non-CSV, anything that's in a cluster can use dual parity. And as I talked about with this gentleman down here, parity and dual parity have integrated journaling for power fault resiliency. Power fault or unexpected failover resiliency. So the resilience of those without the need for a battery. We look at some of the common enterprise workloads. We look at SQL, Exchange, VDI, VMs, okay? IS. We see that there's a very large data set. But guess what? A majority of that data is actually cold. So you can imagine just the most basic example. I have a VHD file. Maybe the VHD file is 20 gigabytes. What do I actually look at when I boot the file? I certainly don't look at 20 gigabytes. I'll look at a much, much, much smaller portion of that file. The rest of it is cold. Minority of that data is in active use. This is called the working set. So I have a large data set. I have a much smaller working set. And this working set changes over time. Changes depending on the workloads. Changes, really, I mean, it changes. It really has to change. You know, your workload is not really static. We also look at the types of drives that are available on the market today. Okay? We have hard disk drives, nearline drives, 7,200 RPM, very high capacity, low in cost. So by deploying hard disk drives, I dramatically lower. By deploying these nearline, very high capacity hard disk drives, I dramatically lower the dollars per terabyte of deploying my storage. We also look at the other types of drives available. SSDs, very high performance, lower in capacity, but high cost. But by deploying SSDs, because they're so dramatically higher in performance, I dramatically increase my IOPS per dollar. So hard disk drives, very large, not as performant. It seems natural to map that large, cold data set to hard disk drives. Solid state drives, high performance, less capacity, less cost. I would buy less of them. But it seems natural to deploy my current working set with solid state drives. But of course, I need a intelligent manner to somehow map their data between these two types of media. And that's exactly what we're doing in R2. Storage tiering. In a single virtual disk, we're utilizing the best characteristics of hard disk drives, high capacity, low cost, to store my cold data. We use the best characteristics of SSDs, high performance, to store my working set. Windows will automatically detect the heat, detect the activity of workloads on this virtual disk, move the hot portions of the workload to the SSD, move the cold portion of the workload to hard disk drives. Tiering occurs. It's a scheduled task, so it's periodic, and by default, it runs every night. What that means is that it looks at a database, figures out what's hot, what's cold, what's changed, what do I need to move around, and it does the movement. And it does the movement in a manner that's completely transparent to your workload. Completely transparent. Your workload continues to run even though the data movement occurs. And that, well, I mean, that's basic. That's very essential. Administrators can also override this automatic placement based on heat. I can set a file to be on the SSD. I can set a file to be on the HDD. Okay? What happens is that, for instance, one of the basic use cases for this is a pooled VM scenario. I have a parent VHD. I have potentially 1,000 desktops with diff disks. By pinning that parent VHD to the SSD tier, I've just dramatically improved boot performance for all those virtual desktops. Or if I want data to remain cold, remain in the HDD, perhaps it's mostly sequentially accessed. I can pin that data to the HDD tier. It's very flexible what you can do. Another capability to maximize the IOPS per dollar is the write-back cache, which is a persistent, and I say persistent because there is no in-memory representation of the cache. It's all on SSDs. It's a persistent, per virtual disk write cache that utilizes SSD capacity to absorb short-term bursts of random small IOs, random small writes to that virtual disk. So when writes come in, when specifically small writes come in, they get staged in the write-back cache before they eventually get destaged to the hard disk drives. They get destaged in a manner that makes them more sequential, because hard disk drives, especially when I stripe them, can deliver amazing sequential performance, deliver me great throughput. So we're trying to make this random I/O, smaller random I/O, more sequential. And write-back cache integrates with tiering. It's complementary to tiering. I can have a storage tier and I can have a write-back cache. Or on the other hand, I don't need tiering, but I need a write-back cache. I can also do that for any simple or mirrored space. Okay? And when I create my virtual disk, I can then specify my write-back cache, what the size of the write-back cache. But by default, we do assign a default size to the write-back cache. And we're still working on the size. But we'd appreciate your feedback before RTM. Let's show a little demo of tiering and the write-back cache. Switch over to my laptop here. I have two perfmon windows, and I have two volumes and two workloads. One volume is with a write-back cache, one volume is without a write-back cache. I have identical workloads. It's SQL I/O. It's doing I/O to both volumes. It's delivering me about 550 IOs per second. So what I'm going to do is introduce write spikes onto both volumes. This blue line you see is the I/O that's occurring right now. It's the SQL I/O. Superimposed with this blue line is a dotted red line. You might not be able to see it, but it's there, trust me. It's a dotted red line that indicates the total IOs per second to that volume. In other words, the IO from this blue line workload and the IO from any other workload onto that volume, which will include this write spike I'm going to introduce. So let's introduce this write spike to both volumes, the same write spike. Firstly, you can see the dotted red line jump on both volumes, indicating more work, more overall work was done. Okay, work from my blue line workload and work from my write spike. The volume, however, without a write-back cache, when I did that write spike, there was a dramatic dip in the performance of my SQL I/O workload, meaning that write spike affected the performance. On the volume with the write-back cache, my SQL I/O workload was unaffected. Let's introduce another write spike. The write-back cache provides the staging area for these random writes that occur to this volume to not affect, or not as affect, the ongoing workloads. Let's jump to the tiering demo now. What I'm going to show you is a seamless transition of a file that's currently completely located on the HDD tier of the volume. I'm going to transition this file to the SSD tier, but the kicker here is that while this file is being transitioned, I have an intensive I/O test occurring to this file. So high queue depth, high number of threads, while the file is being transitioned between tiers. So here's the I/O test going on in another perfmon window. And as I said, the file is completely located on hard disk drives. So it's delivering me about what I expect for these drives, about 2,600 IOPS. Okay? I'm now going to kick this file over to the SSD tier. I'm not going to pause the workload. I'm going to let the workload continue. Let's see what happens. So normally, when I do this processing, tiering would process the request nightly, every night. I don't want to wait every night. I don't want to wait till the middle of the night, so I want to do this right now. So I immediately kicked it off. What it's doing is that the blocks that underlie this file are being transparently moved by the file system from the HDD tier to the SSD tier. The workload hasn't paused. My I/O is actually going up as more and more of these blocks get transitioned between the tiers, as more and more of these blocks get serviced from the SSD tier. It looks like it's done before I even finish talking. So all the blocks are now on the SSD tier. The entire file is located in that tier. So any I/O that was previously occurring to the HDD tier, it's now on the SSD tier. Completely transparent. I'm doing now 60,000 IOPS. Before I was doing 2,600 IOPS. Dramatic difference in performance. And this dramatic difference is the real difference between HDD and SSD. HDD delivers me high capacity, low cost. SSDs deliver me the performance. Switch back. This is the file server cluster as it was in 2012. I have mirrored spaces because that's what I could do in a cluster. With R2, I now have a mix of SSDs and HDDs. I have tiered mirrored spaces. And I have dual parity for my archival workloads. All these capabilities integrate into the cluster just like they did before. There's no difference. There's no difference in management either. Because we're using commodity hardware, Spaces is very flexible as to configurations you can build. The most basic configuration is the capacity optimized configuration, where I want the lowest dollars per terabyte possible. I just want an extreme amount of capacity. Like you saw with the slides before, I had those 4 JBODs, those 4 servers, that gave me a petabyte of capacity, or 500 terabytes of mirrored storage. That's in half a rack worth of gear. Okay? If my workload needs it, oh, sorry, yes?
These JBods also support ODX?
So the gentleman is asking, do these JBods support ODX? So what happens is that we do support, with the Windows file server cluster, we do support offloaded copies. So the whole point of offloaded data transfers, or one of the points of offloaded data transfers, is to reduce the CPU, network, and memory utilization by those initiating the copy. So I don't have to transfer the data from my Hyper-V down to the network, down to the storage, and then back up again. I don't need to do that. Okay? With Windows file server cluster, the data movement gets offloaded to the file servers. So my Hyper-V node is not, and my network between my Hyper-V and my file server is not involved in that copy. So it achieves that portion of ODX without using the ODX command set. And that functionality was actually available in 2012. Yeah. If my workload demands it, I have the performance optimized approach. Greatest number of IOPS. Spaces will scale up to the hardware that you give it. We worked with some of our partners, gave us some hardware, and we did some tests. They gave us a 24-bay JBOD, 3 file servers, 3 high-performance file servers. Okay? So I have 24 SSDs, I have 3 file servers. From this, I created a cluster, and I created mirrored spaces. I was able to get 1.45 million IOs per second out of this setup, out of this 3-node cluster, out of these 24 SSDs. Well, I added another JBOD, same servers. I got 2.7 million IOPS from 48 SSDs. Spaces will scale to whatever hardware you give it. I mean, at the end, it's really your servers, the PCI bus, that's going to be the bottleneck. Bottleneck in throughput and bottleneck in IOs per second. Bottleneck in IOs per second. Spaces will scale there. And what we expect most customers to deploy now, because it seems most compelling for most enterprise workloads, is the balanced approach. I'd use tiered storage. I'd use a mix of hard disk drives, giving me the capacity, and I use a mix of SSDs, giving me the performance. This gives me the best balance between dollars per terabyte and IOPS per dollar. Now, we have a number of partners that provide Spaces certified hardware. And this list, since the last time I presented it just 2 weeks ago, grew by 2 partners. So we have RAID Inc., Fujitsu, Data on Storage. Actually, Data on Storage is on the floor this year at TechEd. We have Quanta, and we have Supermicro. Just 2 weeks, we added 2 partners. We added 3 certified products. More and more partners are coming on board on Spaces. And we expect this list to grow even further as time goes by. We would also encourage you to talk to your favorite OEM and ask them about their support for Spaces. What sort of hardware they have that's certified for Spaces. Ability to do the light blinky, ability to do the enclosure awareness, to place data copies on independent JBODs. The question is, how is this shared SAS being done? So what happens is that the back of these JBODs, they have multiple controllers, just like you'd see in a disk shelf. These multiple controllers have multiple ports. I connect using SAS, using a SAS cable, port from one controller to another controller to a server. Another controller to another server. Another controller to another server. So in this diagram in a previous slide, let me see if I can go back there quickly. This diagram here. So we see that this JBOD, simply by the design of the JBOD, has 2 controllers at the back. The 60-bay JBOD has 2 controllers at the back and 4 ports. So that 4 ports each. So that means it can connect to 4 file servers, 4 servers. Okay? So the unit of this individual JBOD is 4 servers. So if I want more servers, because it's in a cluster, because I have CSV, I simply add another unit. Realistically, when you provide storage, especially storage of this sheer capacity, of this capability to deliver throughput, you'd actually want more servers, because those servers are then going to be the individual bottleneck of throughput. Okay? So when I want to add more storage, I simply add more servers, more JBODs, and I have my CSV. Okay, I have my CSV provide that unified namespace for data access.
You stop connecting the JBoss to more servers.
Yes, I stop.
Connected to the initial 4, and later on, as you add servers, you don't connect it anymore.
Correct. So each individual unit doesn't have physical SAS connectors between them. They just have that cluster network, the CSV, to provide unified data access. And realistically, from your Hyper-V workloads, they don't see how it's implemented in the back end.
Again, if you have like 10 JBoss.
Okay.
Enclosures.
Yes.
So each one of them will connect to 4 physically through task to 4 servers only?
So the gentleman is asking if I have, for instance, 10 JBods, each of those JBods would connect to each of these 4 servers. That is certainly possible. However, when you're starting to get to that many number of disks, you start reaching the bottleneck of the server in terms of ability to deliver throughput. The PCI bus of the servers can only deliver so much throughput. So we always recommend to add some more servers when you reach this. This is about the maximum of a single unit we expect in terms of capabilities of the server. Okay, if you want to add more storage, we would ask you to add another unit. It's a very simple unit of management. Yeah. I mean, realistically, that's the exact same thing with a storage array. If I want to add another rack, that another rack would have to have storage compute as well. It's the exact same model. Yes?
I have a question about the hardware certification.
Yes.
You said that it's commodity hardware, it's standard SAS communication and so on.
Yes.
So why the need for certification? Do the manufacturers
Yes.
need to implement something special to have it work with Windows, or
Yes.
why do you need to certify?
So the gentleman's asking, because the hardware is industry standard, it's commodity, why do we need certification? What does certification do? So at the back of these JBods, there's a SAS expander. This SAS expander needs to implement what's called SCSI enclosure services, which is not uniformly, strangely enough, not uniformly implemented across JBods. Data on storage here would testify as to some of the working with the OEMs to get this certification can be a process to make sure they implement it correctly. And these guys have done a great job of that. So to the JBods itself, the SAS expander needs to, when it presents disks, it needs to be able to also present the correct slot number and present the enclosure ID of that JBod, such that spaces will then be able to know, oh, this drive has failed. I know the correct LED is blinking, and I know that I'm blinking the correct enclosure. And this is what the SAS expander at the back needs to do. It needs to respond to these commands.
So if we already have JBoD storage boxes, we cannot utilize them for
So the gentleman is asking if I already have JBods, can I utilize those for 2012, 2012 R2? So it really depends what JBods you have, and it depends on what capabilities you need. If you need the capability to do light blinking and you do the enclosure awareness, you need Spaces certified hardware. We'd encourage you to try it, though. You can use those JBods certainly as a test bed, but if you want the maximum ease of management and maximum functionality, we'd recommend you use Spaces certified hardware. And the JBods themselves are inexpensive because there's really not a lot of logic in them. Metal, backplane, SAS expander, and power. That's really all they are. So they're very inexpensive units.
they cannot be certified since they were manufactured before 2012 R2.
So the gentleman is asking, can they continue to be certified? Maybe the vendor might have firmware updates for it. And we've seen that in the past, where firmware updates do bring JBods up to a certified state. So I'd encourage you to work with the vendor to see what their support is for Spaces. May I ask what JBod it is? I'm just curious. Oh, if you don't know, I can. Yeah, we'll ask later. Okay. So let's back. Okay. So the list of partners is growing. We have 5 partners now, and it's going to continue to grow as time goes by. Windows Server 2012 R2, with all the full stack, storage spaces, clustering, file server, Hyper-V, is a key component in your public or private cloud. Delivers cost efficiency, scale and capacity. You can scale to those huge data sets. You can get the amazing performance out of your hardware. And it's continuously available. Provides resiliency for your data and is continuously available. You saw customers using Spaces who achieved doubling of their throughput. They cut their capital expenditure by 1/3. They increased their capacity by 5x, and they culled 8 full racks full of gear due to the density possible with Spaces hardware. So we have a number of other sessions. Well, it's the last day, but I'm sure you can go back and look at the website to find out more information on these sessions. Great sessions, great information. So the bits are available, preview bits. We definitely encourage you to try Spaces, whether it be certified JBods or not. At least those JBods you can still continue to use as a test bed, as long as they provide raw disks. They're not RAID JBODs or anything like that. We definitely encourage you to try Spaces. You can try Spaces within a VM. Again, it's not something we'd encourage for production environments, but you can definitely try it. And for many of our demos, we actually do use Spaces in VMs. And we definitely also encourage you to try System Center as well to manage your entire stack. All right, well, I'd like to open the floor to questions. If you folks have questions, I can answer them now, or I'm going to be at the storage booth right after this over in the modern data center area of the hall, so I can answer your questions now. It'd be great if the floor staff would be able to help pass the mics around, especially towards the back, like this gentleman over there.
So how will the tiered storage be beneficial to a VM workload? Because the VMs typically are quite big, and part will be database, part will be something different.
Yeah. So tiering, in this stack here, we expect all the workloads to be virtualized. We expect the volume to consist of multiple VHD files, really from multiple VMs. What tiering does is it actually looks at heat at the subfile level. So we look at heat, we track heat on 1 megabyte granularity, something not too small and something not too big. Using that 1 megabyte granularity, we then move the appropriate portions of the file, portions of those VHD files, to and from the tiers depending on how hot they are. So we expect to be able to handle a large number of different workloads, and we're actually working on collateral and documentation on a number of different workloads to figure out what is the recommendations for provisioning and configuring different parameters. So we're working on workload recommendations as we speak.
Okay, just another question. Do you know whether HP is working on certified storage?
Something that you can probably ask HP down at the floor. But no, Spaces, HP doesn't have any Spaces certified hardware at the moment. Any other questions? Yes, sir. Thank you.
So we got server hardware, and there's always a RAID controller on board. So how do I use Spaces without having extra cost for a SAS adapter? And what is the difficulties running Spaces behind the ports of this RAID onboard adapter?
Yeah, so it's a very common question we have in different flavors. I have a fiber channel array and I want to use Spaces on top of it, or iSCSI array, or RAID, or what have you. So the problem with putting Spaces on top of RAID or any other device that has embedded intelligence is that those devices, if for instance an underlying disk fails, we're not getting notifications. We're not getting notifications up to the user level. It's very difficult for an administrator to map how my health is of my actual disks behind Spaces because there is no visibility. There also could be other issues of functionality and performance because we are going through another layer. Spaces really needs to have raw disks. You get Spaces certified hardware. You can do the LED blinky. You can do the enclosure awareness with just simple hardware. And it really is the most cost-effective approach. So we cannot use Spaces on top of RAID controllers. Perhaps you could use eBay to sell your RAID controller and get a HBA instead.
Well, it's always on board, so you can't pick it out.
Yeah, that's
Thanks.
true. That's true. Yes. Oh, yes.
As this is available, do you really need it? But okay, as it is available in standard server and of course in data center, yes. What is the added value of Windows 2012 Storage Edition?
So I'm not as familiar with the SKUs. Our team is core Windows. We build the technologies for server and client across all the different SKUs. So again, I'm not as familiar with SKU level differentiation. There might be some staff on the expo floor that might be able to help you with SKUs. If they can't, just give me your card and I can go find that information for you. Again, I'm not as familiar with SKUs. But Spaces is available in all SKUs. Available on the client, available on server. Tiering is only available on server, but yes.
Are there any built-in features to support quick backup of such large amount of data?
So as we expect most workloads to be virtualized, including virtualized file servers providing data up to clients. You can use Hyper-V Replica to back up your data, or you can use existing backup methods to back up data at the file level, at the file servers. So those are methods to back up your data. Yeah. So the gentleman is asking, I can also use DPM, DFSR. Those are methods that you can use to also back up your data. You can have volume snapshots. There's many different methods to back up your data. Yeah. Any other questions?
Two questions, actually. Is there any documentation about the heat algorithm?
Yeah, so, well, there is, at this point, there is no documentation on tiering. We're working on that, but our heat algorithm, portions of that we would not document. We would simply describe what are possible configuration options and recommendations for the algorithm, for the heat.
It's mainly to be able to make the best decision how to lay out your storage. And if you have some insight in how the tiering works, you can do that better.
Yeah, we're thinking of doing a deep dive, either in a presentation or maybe documentation, and we might consider putting some information there on the exact metrics of our heat algorithm. But again, it's something that we worked with Microsoft Research on. Just like with any storage array today, it's mostly proprietary IP, the specific algorithms we would use to determine heat and prioritize block placement, et cetera, and so forth.
Okay. Then the second question, I would like to second the request by the gentleman. I think it would be a nice feature for any vNext version that the replication or the backup capabilities are provided somehow with storage spaces, because that might be one of the bottlenecks we're going to hit if we are going to leverage this storage solution for massive amounts of data.
Okay, that's good feedback.
Okay,
Thank
cool.
you. Any other questions? All right, well, thank you so much. Have a great day.